Okay, so today we're talking about something a little bit different. It's still related to what we've been doing with the ratio and proportion and stuff. We're going to talk about variation. So variation is a very powerful tool. If you know the relationship between two amounts and you have some sort of initial condition, even if you don't know the formulas or the rules that govern it, you can come up with them basically just by knowing the relationships. So there's two main types of variation. We'll talk about a couple other subtypes later. But the first main type is direct variation. And this is what we're used to talking about. Direct variation is a constant ratio, or equal ratios if you want to think of it that way. In direct variation, A over B is equal to little a over little b. The two things that are related have the same ratio to each other. Basically what direct variation is if one value gets larger, let's say our x value gets larger, the y value also gets larger. So we could write it as a proportion like this, or we can write it as y is equal to a constant times x. Or we could write it as y over x equals a constant. Again, that kind of builds into that whole constant ratio thing, proportional. Things that have direct variation are proportional, like the similar triangles we talked about. If one triangle is an enlargement of the other, it's direct variation. One side gets larger, the other side gets larger by the same ratio. Let's do some examples here, though, of direct variation, how it would work. So let's just write out P varies directly as M. What does that mean? Or P varies directly with M, or however you want to do it. Sometimes I might say P is directly proportional to M, whatever. What this is saying is that P is equal to a constant times M. Let's take that a step further. Let's say we were told Q varies directly with Z Q is 18 when Z is 6. Now there's two pieces of information here. Q varies directly with Z means what? Q equals K times Z. Very good. But then we also have the second piece of information. Q is 18 when Z is 6. So we can use that to define this relationship even further. That's what we call an initial condition. We know the relationship between the variables. We go out and we find a spot where those two variables interact and we take some measurements, or we take some readings. So if Q is 18, when Z is 6, we get 18 equals K times 6. And now, of course, we can do what to solve for K? Divide by 6, which gives us that K equals 3. And once we know that K equals 3, we can get a better definition of this relationship by saying, instead of Q equals K times Z, we can say Q is equal to 3 times Z. And we now have a much more defined relationship. Make sense? Well, the next step. I'll word this one a little bit different. Y is directly related to X if Y is 48 when X is 3. Find Y when X is 7. Now there are still two pieces of information here, and then also a question or a task. we still have y is directly related to x, which means y equals kx. Same as saying y varies directly with x. Next piece of information is what? K times 3. Very good. Y is 48 when x is 3, so we put in 48 for y and 3 for x. 48 equals k times 3, so now what? Divide by 3 to get 16 equals k, which means y equals 16 times x. The next thing we have then is a question or a task that we're given. Find y when x is 7. How would we do that? Yeah, we put 7 in where x is. 16 times 7 is 112. Y equals 112. So you can see here is a situation where we don't know anything about x and y other than the fact that they're directly related. We had an initial condition. Y was 48 when x was 3. And we know, well, if we want to change x to 7, can we predict what y is going to be? And we can, with very little background information. Let's say y varies directly as the square of p. If I is 75 when p is 5, find I when p is 4. So how's this one different? Yeah, it's not I varies directly with p, it's I varies directly with the square of p. So it's I equals k times p squared. Very good. Next step. Yeah, 75 equals k times 5 squared. So now I've got to do the 5 squared. So 75 equals k times 25. And then dividing by 25 tells us that 3 equals k. So I equals k, or sorry, not k anymore. I equals 3 times p squared. And then well, we put 4 in for p. So I equals 3 times 4 squared. I equals 3 times 16. I equals 48. Good stuff? Sure. Okay, so now the other type of variation we can look at is inverse variation. In inverse variation, if the value for x gets larger, the value for y has to get smaller. This is what's referred to often as a constant product instead of a constant ratio. In this case, what it would be is, a times b would be equal to little a times little b. Or the other way of thinking is x times y equals a constant. Or more often, more useful usually is y is equal to a constant divided by x. Examples of this would be if you're dealing with pulleys or gears. The larger the gear is, the slower it turns. So bigger gear, fewer RPMs. Or larger a pulley, the slower it turns. Same thing. One number gets bigger, the other number gets smaller. So let's take a look at some examples. Let's say that we tell you that M varies inversely with D. We'll just go the whole route here. If M is 7 when D is 9, find M when D is 3. So again, M varies inversely with D, means now instead of M equals K times D, it's M equals K divided by D. Because if D gets larger, M has to get smaller. If we double D, it has to cut M in half. Next, M is 7 when D is 9. We put in the 7 for M, the 9 for D. What can we do from there? Multiply by 9 gives us that 63 equals K. So that tells us M is equal to 63 divided by D. And then that's the K. Thank you. No extra charge for the 6. What's that? Okay, we put in 3 for D, because find M when D is 3, M is 21. What if you guys try one? Just need that for a second. Q is inversely related to the square of n. If Q is 9 when n is 4, find Q when n is 12. Actually, not 12, 6, I was going to say. Tell me where to, actually, let you guys try this. I'm going to pause this and let you guys try this. Let's see what you got. So Q equals K over n squared. And then, what from there? 9 equals K over 4 squared. So in other words, 9 equals K over 16. And then, times 16, 144 equals K. So Q equals 144 over n squared. And then Q equals 144 over 6 squared. 6 squared just happens to come out to be 36. So Q equals 4. What do you think? More fun than a barrel of rabid monkeys? Yeah, you gotta be careful for those. Okay, so now we're going to talk about what happens when we combine more than one of these variations together. We might have something like this. R varies directly with M and the square of p. And inversely, with the square root of q. If r is 2, when m is 3 and p is 2 and q is 144. Find r when m is 5, p is 3, and q is 25. This one's a little more complex. Just a touch. But we start out the same. R varies directly. So R equals K. Directly means it's going to be times or divided by. Times. With M, so R equals K times M. And the square of P. So P squared. And inversely with the square root of Q. So divided by the square root of Q. So we've set up our relationship right there. So it's really no different, just you got to read it and be careful to put everything in the right spot. Now the substitution and calculation is going to be a little trickier, but we can handle it. R is 2, so we put 2 here, 2 equals. We're still looking for K. When M is 3 and P is 2, so that's 2 squared, over the square root of 144. Now remember, when we have this fraction bar here, this means divide, but it's also an enclosing symbol. If you go back to your order of operations, it means we have to do everything we can on top first. Then we do everything we can on bottom, and then we divide if we can. So on top, obviously we can't do anything with the K, but we do have 2 squared is 4 times 3 is 12. So that's K times 12. On bottom, we have the square root of 144, which is 12. So now, to solve for K, I'm going to multiply by 12. So 24 equals K times 12. And yes, I do realize some of you might just say, let's divide out the 12s and cancel them out. You can do that. I'm just being more proper here. And then we're going to divide by 12 to get rid of the 12 times K. We get 2 equals K. So K equals 2. So that brings us up here to tell us that R is equal to 2 MP squared over the square root of Q. What's next? Well, we're trying to find R when M is 5. So 2 times 5, and P is 3, so times 3 squared. And Q is 25, so the square root of 25. Everybody with me so far? You need me to pause? You're good? So on top, obviously we have to do the 3 squared first, which is 9. 2 times 5 is 10, times 9 is 90. On bottom, square root of 25 is 5. We divide that out, we get 18. R is 18. What do y'all think? You ready to take one in the eye? Before you start opening your books, this is actually a worksheet I'm going to hand out to you.